So we'll get started in a moment. Good morning, friends. This is Durga from IT Varsity. Those who are joining from YouTube, today's session, actually this session is part of a bootcamp program which we are running for past 2.5 months. We just want to give an idea how our training goes. That's why we are opening this video to public. It might be means we might not be able to take any questions from you. So if you have any questions, you just have to follow up with us at a later point in time. But you can understand how our training goes. So here we are waiting for more people to join, and then we'll get started. So today we'll be talking about Hive DDL. We will get into very basics of Hive DDL. This is a 4 to 5 month bootcamp program. So the pace will be a bit slow, and we'll be talking about a lot more internals to actually understand how Hive works. Okay. We are just waiting for more people to join. So just bear with us for a moment or so. Okay, let us get started. So here I am connecting to the lab. And I'm launching Hive. Yesterday, I have asked the question for people to figure out the difference between char and varchar in RDBMS like Oracle, MySQL, etc. So we will come back to that towards the end of the class, not now, and then you guys can explain. For now, we'll directly get into DDL. So when it comes to DDL, I just connected to Hive. Means I'm launching Hive here. So I have already created a database yesterday with the name, I think, bootcamp demo. Yeah. So this is the database which we have created yesterday. Okay. Now we are talking about DDL. Typically, I follow the official manuals to understand the syntax and semantics of any technology and learn and explore further. So you can Google for the official documentation by saying Hive manual, and you can get here. In this, DDL means data definition language, which is nothing but creating tables, dropping tables, truncating tables, altering tables, and adding columns to it, etc. So here we'll start with DDL, and the main thing which you need to understand is once you get to this language, Hive manual, under data definition statements, you can see DDL statements. If you click on it, it will take you to a separate page which is related to Hive. Okay. And if you zoom in and if you scroll down, there is a big square box here, which gives the syntax. Okay. Go to any database technology and check the syntax of their SQL or DDL or DML. It will look like this. It will exactly look like this. Okay. So all the words such as create, table, So all those which are not in square brackets, they are mandatory. So if you want to create table, you need to have create table and then rest of the stuff. Okay. In this case, to create the table, you have to at least have create table and table name. You can see here. And if you observe, this create table are in caps, and then DB name and table name are in small letters. So all those which are in caps are keywords. Okay, keywords means database or underlying technology will interpret those things in a certain way. Okay, and they are language specific or technology specific. Every programming language, every scripting language, every database technology will have at least some of the keywords, if not many. Okay, typically database technologies will have keywords like create, table, alter, comment, partition by, clustered by. All these are common across all the database technologies, not just Hive or Oracle. Okay, then all those, and also you can see some differences here. If you see temporary is in square brackets and this is not, which means these are optional. But when it comes to columns, okay, so this is the specification for columns. They are saying column should be defined as column name, data type, etc. And if you look at that section, it is in circular brackets. In square brackets, it is again in circular brackets, which means we need to at least have one of them. Okay, so at least we need to have one column name along with the data type, and along with column, comment is optional. If you want to give comment for each column, you can give. The typically the column names have certain restrictions. You cannot have longer column names. You cannot have column names beginning with numbers, or you might not have any special characters in them. That makes the column names cryptic because you cannot have spaces. If you don't have spaces, if you have a complex name, means with multiple words, it sounds cryptic. To address that, most of the database technologies support comments, and you can optionally give comment for each column. Okay, so the circular bracket in the square bracket means there should be at least one of them. Again, within that, you can see comments are optional, and also if you want, you can have constraint specification. You can define the constraints, and then you can have a optional comment at table level. So the ones which are in circular bracket in the square bracket, the upper one, the comment is for each column. Okay, so once you define all the columns, then if you want, you can define comment at the table level to tell what is the table for. Then we will talk about partition by, clustered by, skewed by, etc. at a later point in time. Then there is a optional very important clause called row format, which we'll be seeing very soon. And why we need to understand that, I will explain that. And typically these are used for text files only. Okay, because text files will have records with a particular delimiter for field and for row, or for each line. Okay, there won't be any metadata within the file, except for column names in some cases. Okay, as text data will not have metadata for each record, we have to tell how the records are formatted in our data. Okay, that's why this row format is important. But when you actually insert into Oracle tables, or when you create Oracle tables, you don't specify row format. I will explain that reason in a moment. And then optionally we can specify the location. We'll get back to that at a later point in time. Now to define the columns, if you look at the syntax, it takes column names and data type. Each column name need to have a data type. Both are mandatory. Okay. If you look at this data type, column name is what you give. But when it comes to data type, typically in some cases, like Oracle and all, those data types and all will be specified with some special character before, but here in Hive documentation they do not, which means that there is some material related to that at a later point in time. But in this case, they do not highlight like that. But in some cases, like or in some database technologies, when they document, if there is a additional material for one of those keywords, which is part of that main create table syntax, they will represent in a different way. And then they also might give you URLs for that. If you click on that, it will take you to appropriate section. Okay, in this case, data type is one such type where you need to understand more information, and others are this row format. Even row format, you need to go elsewhere, and you have to understand what is row format. But in this case, Hive have very limited syntax, and hence you have everything in this square box itself. So if you want to know more about data types, you have to come here. If you want to know more about row format, you have to come here. Okay. Now when it comes to data type, yeah, if you see again, there are primitive types: array type, map type, structure type, union type. These are the complex types. So you have primitive type and complex types. Primitive types are these things: tiny int, small int, big int, boolean, float, double, all numeric types, boolean, and alphanumeric, char, varchar, date, timestamp. All these are considered as primitive types. Okay, and then you have complex types also. Array type syntax is like this. Map type syntax is like this. Structure type syntax is like this. So when you define the columns, you can define complex types also. What are these complex types? We will talk at a later point in time. Okay. And then when it comes to row format, you have to tell how the rows are formatted if we are talking about text files. Otherwise, we don't need to. Even in text files, it assumes certain defaults, and we need to understand that also. I will cover those. Now comes file format. By default, text file is the file format used. Okay, but Hive also supports other file formats such as sequence file, RC file, ORC, Parquet, Avro, etc. So as part of the Hive, we will primarily focus on text files. I will give some examples from the syntax perspective, how to create other file formats, how to load data into those things, etc. But I will not be getting into internals of those file formats. Either you need to explore them by yourselves, or once we talk about Spark, I might conduct 1 or 2 sessions on file formats itself, and I might get into details at least about a couple of file formats. Okay, that depends upon the pace which we go with. Okay, then comes constraint specification. You can define primary key, foreign key, etc. But these are not enforced. Okay, they are only for informational purpose. They will not be enforced. Okay, but in Oracle and all, they will be enforced. Let us get into details about how to create table now. Again, we will be loading some data, and we will try to understand the difference between traditional RDBMSs and Hive, so that we understand some important phrases like schema-less, or schema at read, schema at write, etc. Okay, so I am connecting to apex.oracle.com, where I have my Oracle database. I think they have changed the. Okay. Now, typically, when we say create table in Oracle, we just give create table, table name, let's say demo, and then we define the column names and data type. Okay, let's say I want to create I of type integer, column I as integer, S for string, and V with varchar of 3. Okay, I'm running this query. Okay, so you can see there is no string type in Oracle. That's why it is failing. Now I am also defining. I'm defining this also as varchar2 of 100 and run. Okay. Also, let me create one more variable c care of 5. I have to drop this, drop table demo. So this is a typical table in Oracle. Okay. And when you run insert command, the data has to be stored somewhere. Where it will store? So in Oracle, there is something called table space and a database file. So database file is nothing but a file like our text files in our system, but it can be understood by Oracle only. Okay, no one else can understand that, which means we have very limited control on the way how Oracle will actually store the data. Okay, we can only interact with the data through SQL. So if I have to insert the data, I can only say insert into demo values 1 comma hello comma. In this case, we have to use single quote only. Hello ITV and then world. So we typically insert data like this. And another way is if you have data in another table, you select from the table, process the data, and insert into table. So you can either insert individual records like this, or you can actually um, uh, insert using select query, where you get the results from other table and load into this. Okay, and as part of select, you can have whatever logic you want. So these are the typical two ways which we load into the data. And there is a third way also. What is the third way? Let's say you have a file, external file, which is comma separated. And if you want to load the data in Oracle, into your Oracle table, what we have to do is we have to use tools like SQL loader. There is something called SQL loader. So what it will do, SQL loader is again Oracle's proprietary tool or software, which can process data based upon certain rules. At the time, we have to tell how the data is formatted in the files. And then SQL loader is smart enough to convert that data into individual insert statements. There's something called direct path load also, which you can ignore. But typically, in earlier days, what SQL load used to do is it used to process one record at a time with the information that is passed. In that case, we will be saying what is the field type, what is how the data is delimited. All those things we have to pass the information, and then it will convert your data into individual insert statements, and it will issue against the database table, and then data will be copied into the whatever file the table is using to store. Okay, bottom line, whether you use insert command with individual record, or you say insert into by selecting from another table, or whether use SQL loader. Internally, it insert one record at a time only. It will not insert all the data in bulk in one shot, because whatever format you give it, whatever in whatever format you give the data to Oracle, it has to convert as per its standard, as per their logic, the way they want to interpret the data. Okay, so it's completely controlled by Oracle. The complexity is hidden from us. And also, as I have demonstrated Apex and all earlier, the similar tool for SQL loader is, if you go here in SQL workshop, there is utilities, and in this there are some, 1 minute. Yeah, you can see utilities data workshop. You can download the data from the table. You can upload the data also. When you say upload, it will ask you how your data is formatted, and you have to tell that, and it will take care of converting each and every record into insert statement, and it will insert into the table. Okay, so we typically use insert to some way or the other, directly or indirectly, into to load data into Oracle table or any other RDBMS. It is not only with Oracle. Even if you talk about MySQL or Informix or DB2 or SQL Server, take any database technology. Once you give insert statement, it will be compiled into whatever logic uh, they they want to use, and whatever format they want to save the data. Okay, the complexity is hidden from us, and we'll be using only the insert statements to interact with the table to load it. To read it, we use select. On top of it, you can also use update. When you say update, because the Oracle can process one record at a time, it can identify where the record is in the file, and it can go and update the record. Okay, that is how it happens in Oracle. When it comes to so one thing which you need to understand is, if I need to look at the data directly for the table I have created and for the data I have inserted, there is no way in Oracle. You cannot go to the database file where the inserted record is, and you cannot directly see the data. Okay, but when it comes to Hive, yesterday we have created table in Hive similar to whatever we have created in Oracle, and that table name is also demo. Okay, you can describe to get the details. There are 3 fields, and as I have explained yesterday, the data will go to HDFS, the metadata will go to Hive Metastore. Okay, and then when you run select query or insert statement or whatever it is, it will first check Metastore for semantics purpose, and then it will compile into some map reduce job or whatever it is to load the data into the table or to read the data from the table. Okay, now when it comes to this, if you run describe formatted, it gives the location. Even in Oracle also you can get that location. Let me go here. Even in Oracle also you can get that location, but I doubt whether we have permissions to it. Let us see. If you go to SQL commands, our table name is demo. Okay, there is a metadata table called user underscore tables. Okay, and these type of tables are in Hive Metastore for us. So if you want to get information about tables, you can go to Hive Metastore and you can get the information from there. Okay, you can use commands like describe table even in Oracle, but it will not give where the data is and all directly. If you want to know those details, you have to either extract the DDL or you have to query the metadata tables like this. Okay, you can run. You see here, we are talking about demo, and this is the table space name. And if you have access to system views, and system views, the typical developers will not have access to directly. Only Oracle administrators will have access to. We can go to this. There is a table called DBA table spaces, which is accessible only for system admins, and they can actually say self star from DBA table spaces, where table space name equal to this one, and it will give the file name in which the data for this table resides. Okay, but if you actually use describe formatted, if you actually use describe formatted in Hive, it gives the location directly. Okay, and in Hive we can actually say where our data is. We can actually read, and it will be like plain text format only. If the table type is using a text file to store. Okay, there is some background noise. Let me mute everyone. So now I can actually query this location by saying dfs-ls and paste it. You can see the file here, and you can also run cat command on this dfs-cat and paste the path, and you can see one hello WR. It doesn't mean that it is only one word. Actually, there are 3 words, but the separator is null character. It's not space. By default, Hive uses null character. That's why it is showing back to back like this. If I come out of this, and if I say Hadoop fs-get, so this will actually copy the data from HDFS location into my local system. So I'm trying to copy the data which is in HDFS, pointing to which my table is pointing to the local file system, so that I can view the data. Okay, so I'm copying the directory directly, and then I can go to this. A directory will be created here because I copied the directory, not the file. And if you look at it, there is a file, and if you say view, give that file name, you can see this control A character. This is nothing but ASCII null. Okay, but when you say cat, as it is printed in on console, it will replace with nothing. So here we are using a special character called null character as default. In case of create, so not we, but Hive is using a special character called null as default while creating the tables when we do not specify the row format delimited clause. Okay. So now let us understand few more things. Yesterday we have created the table, and also we inserted the data. And when we inserted the data, let us revisit the column names and data types, and then we will talk more about it. Okay. So we actually created a column called V with varchar of 5. Sorry, varchar of 3. Let me. If you just want to get the column names, you can just say describe demo. It will just give the column names. There are 3 columns. One is I, second one is S, and third one is V. And when we run the insert statement yesterday, we inserted like this. Even though V takes only 3 characters, we try to insert with 5. Okay. If we do that in Oracle, it will fail. Insert into demo values. We have 4 columns here. The first one is I do not have any primary key, so I can insert the same record multiple times. But I forgot to save earlier. But let us see. Hello. and then it takes only 3 characters, but I'm trying to pass 5 characters. And let me run this. There are 4 fields when I created the table in Oracle. You can see here. So we actually take 5. Actually have 3 varchar of 3, but we are trying to pass 5, and hence it failed. Okay, but in Hive it worked fine, but it just trimmed the characters. Now, when it comes to Oracle, you can only load the data in the way insert does. So whether you use insert into and pass the individual column names, column values one at a time, or whether you say select star from and then insert into a table, or even if you use SQL loader, in all the 3 cases, it actually perform the load 1 record at a time. It does not load more than 1 record at a time. Okay, that is very, very important point to understand. Again, I am repeating, whether you use SQL loader and try to load hundreds and thousands of rows, or run insert command by selecting data from another table, or run hundreds of thousands of individual insert statements with values. In all the 3 cases, internally, it will at an atomic level, there will be only 1 record inserted at a time. When in each individual record will be written to this file on which the data for this table is represented. Okay. Now, when it comes to Hive, even if you run, except for insert into and load the data individual records into the file, whether you query data from another table and insert into the table, or if you want to load hundreds of thousands of records, instead of running insert command type of approach which SQL loader follows, we can just copy the data into the table. Okay, so let me explain what I'm talking about. I am opening another session here. Sorry, first I need to connect. So I will not be connecting to Hive, but I will be creating a file. Okay, so the file name is demo.txt. Okay, and I'm okay. I need to have the control A character. So to fix this, what I will be doing is I'll be dropping the table. I'll be dropping this table. Also, if you already have table and if you want to get the syntax of the table to recreate with some modifications, what you can do is show create table demo. That gives the actual create table command which will be executed internally. So if you say, see, yesterday I just said create table demo and I have given int as a string v varchar 3. I haven't given other things. Even though you explicitly do not give the row format, stored as, etc., it actually used some defaults. Okay, so if you want to find the exact syntax of the create table which is being executed to create the table, you can say show create table. And in this case, I'm not interested with everything. I'm just interested up to here. I'm copying this and I'm opening Sublime Text to make few changes to this. The changes are primarily the row format delimited. Don't worry too much about it. I will explain once again. For now, just to demonstrate how data can be loaded in different ways into in Hive, and how functionally they are different. Okay, so for that I'm just trying to use comma separated files rather than special characters, so that it is easier for me to generate the data and load. That's the only intention. I'm using row format here. So even if you do not understand what it is all about, don't worry about it. I'm just saying whatever data loaded into this table have to have comma as the delimiter between the fields. So row format delimited fields terminated by comma. Okay, now I can copy this and I can paste it. It will fail. I can say drop table demo. Okay, now the table is created. Okay, so one thing you need to understand between Oracle and Hive is, in Oracle you cannot directly deal with files. Okay, if you don't have enough permissions, you even do not know which file have your data. It's completely hidden from you. Only Oracle understands which file the data is in for a given table, and only Oracle can write into that directly. All you can do is you can issue a command called insert, update, delete. You cannot do anything else directly on the file. Okay, so your data SQL engine can understand how to deal with the files directly. As a developer, you will not be worried about it. Whereas in Hive, the Hive engine, so Hive engine is the one which actually executes the query. The Hive engine and the data are loosely coupled. Okay, so Hive do not have direct control. Sorry, Hive engine do not have direct control on the data. Okay, when you so in this case in HDFS, you have a lot of data already. Now we are actually trying to create tables. In Oracle, it is not possible. If you have data, the data has to be part of table only. Otherwise, you cannot have data. But in our cluster, we already have a lot of data in HDFS, and there are no files for them. Okay, because your data layer, which is HDFS, and Hive engine. Hive engine means the jar files which query data from HDFS, which load data into HDFS, all those things is loosely coupled. As they are loosely coupled and separated, you can interact with the data in HDFS in multiple ways. One such way is Hive. You can use Pig to interact with the data. You can use Spark to interact with the data. There are many technologies which you can use. Okay, so the main thing which you need to understand is the data layer and execution engine are loosely coupled. Okay, so now that's why we are able to see where the data is. We are able to copy the data. We are able to see how the data is structured. Actually, in this case, we are telling data should be structured like this. When we create table, there are two ways. Either you can create a table on the already existing data, or you can create the table and get the data into that. Okay, if you are trying to create table on the data which already exists, we need to understand our data, and based on that, we have to define the create table. If you define the table without data, then you have to satisfy the table structure while loading the data into the table. Okay, so now let us focus on the second part. We have created the table, but there is no data in the directory. The directory is just created. The demo directory under whatever database we have is just created, and you can confirm that there is no data in that. There is no data here. Now, how to get data to here? There are two ways. One, insert. Actually, three ways. The same three ways which we spoke in Oracle. Either you can actually insert individual records. Second, insert the query results. So write a query and use it as part of the insert clause. Third, load data from external sources. These are the three ways where you can load the data into Hive. We have already seen the first scenario using insert into table. We have passed the values and it inserted the record. I am running once again. Okay. I am running once again. If you look at this, when it comes to Oracle, when I say insert, it happened just like that. It came back immediately. But even for one record, you see how long it is taking. Okay. The reason is Hive is not designed for atomic inserts. You should never use Hive to insert one record at a time. It's a very rare scenario where you might use in the real world cases. Okay, so even though Hive supports insert, update, delete with many restrictions. So insert, you can insert into almost all the tables, but update, delete can be done only on certain tables with many restrictions. Even though they are possible, you should not use it. Okay, just for learning purposes, if you just quickly want to insert the data, you can do this way. Otherwise, you should not do it. Okay, and the second approach is query the data from other table and insert into the table. That actually run MapReduce job and load the data for you. But when it loads, it will not deal with individual records. So the query results will actually be cached into memory, and all the data will be flushed into the file in one shot. We will see that at a later point in time. The third one, which is important to understand, is load command. Or the actual scenario in the project is to load the external files into the Hive table. Let's try to do that. Let's try loading the data which is in outside. Sorry, what external sources. Let's try to load the data in external sources into Hive table. Okay. So for Hive, there are two external sources. One is the local file system from which we are trying to log in. Second one is HDFS, which are not related to the table or database. Okay, so there can be two external sources. One is the local file system of that server on which we are connected to. Second one is the other locations in HDFS. Okay, so these are the two sources from which we have to load the data. For now, I will be limiting the discussion with respect to loading data from local file system into the Hive table, because here the intention is to not to explain the load in detail, but to make you understand how it works internally when we create the table and when we try to load the data, especially in the context of differences between Oracle and Hive. In Oracle, if you use SQL loader, you have to just tell what is each field type, how the data is separated, and then it will convert each line with that format into an insert statement and load it, and it will load into underlying database. Here, let us first cook up the data. We need to have data. I am storing multiple lines. One, hello world. Okay, second one, some random data with only two fields. Third one, again three fields, but with a different delimiter. I have used all the combinations. Okay, so in this case, when we actually use when we want to load the external data, we have to use a command called load. So when you use load command, it actually copies the file directly into that location. It does not do any processing. It will just copy as is. As our data is not in compliance with our structure, as per our structure, what we are expecting, each line has to be comma separated between the fields. Each line has to be new line character separated by default, and each field within the line has to be comma separated. But one line have 3 fields with comma separated, but here world have 5 characters. There we have defined the third a column name with only 3 characters. And then there are 2 fields with comma as the separator between them, and third one with some weird stuff with some colon as delimiter. And then we also have one record which actually satisfies the schema. Okay, so there are 4 records in this case. Now I saved it and came out. Let's say use pwd to check the path, and demo.txt is in this location. To load the data, the syntax is load data. Don't worry too much about the syntax at this time. I will cover that a bit in detail. Just understand my intention. I'm trying to copy the file from the local file system into a Hive table, and I want to explain how it behaves. So the syntax is local in path home training demo.txt, and then into table demo. So if you see, it loaded very fast, whereas with respect to insert, just for one record it took 15-20 seconds, but here it loaded within 1 or 2 seconds. Even if you have few gigabytes of data, it will be done within 3-4 probably 10-15 seconds, not more than that. So depending upon the volume of data, it might take some time, but it will be very, very fast. The reason is it is not converting into insert statements. It is directly copying the file as is into the HDFS. Only thing it will do is, if it is a large file, it will be divided into blocks, and those blocks will be scattered across all the nodes in the cluster. That's the only thing it does. Apart from that, it does not validate the data. In this case, you did not see any exceptions, even though the data is completely non-compliant with our structure. Okay, it does not do any type of validations on our data. It just copied the file as is. Only thing is that as it is a copy to HDFS, if it is a 10 GB file and as our block size is 128 MB, there will be 80 blocks, and those 80 blocks will be scattered across all the nodes in the cluster. That's the only thing that will happen. Apart from that, it will not pick each record and try to convert into insert statement and load into Hive. It is not it will not happen at all. And this is very, very important to understand. Okay. Now let us select from this table. We have 4 records, right? And what happened? What happened? First one is the record which we have inserted. So it applied the schema. And while inserting itself, it actually loaded only 3 characters. The second one is also showing exactly the same way. Okay. But we will see how it is represented internally. The third one is, it is, except for second one, the other 2 are showing as nulls. Fourth one, it is showing all as nulls. And fifth one, it is showing the values the way we have in the file. It has shown accurately. Now let us see describe formatted on this table again, and let us see what happened here. Already we inserted one record before loading the data. We did not load the data directly after creating the table. We inserted one record, and when we insert the record, we mentioned 5 characters as part of the third column. Okay, and then we loaded data which have 4 fields. So it has shown both when we say select star from demo. Now let us say dfs-cat. You can see here. So the first record is the result of, so before even doing this, let us do ls, dfs-ls. not insert, but ls, and hit enter. So there are two files. What is the format of first file? 60_0, which is system generated name. That is not the file name which we have given. We haven't specified that file name anywhere. So its system have generated it. But the second one, whatever file we have, whatever we copied, the same file name is used. Okay. If you run the load command again, it will append like demo underscore copy underscore 1, demo underscore copy underscore 2, etc. The file name will change, but the contents will remain same. Okay, you can copy the same file any number of times. Each time the file names will change. It will not be just demo.txt like this. That being said, you have two files. Let us check the output in the first file, dfs-cat. Okay, there is only one record. Even though we said world for the third field, it only inserted 3. So it applied the schema while inserting up to an extent. And then if you say dfs-cat and see the output from this file, it is same as what we have in our local file system. You can see here 1, hello, world. It's not WR. But when I select, even this is showing as only WR. The reason is the column data type is specified as varchar of 3. Okay. So even though there are 5 characters for the third field, it is only showing 3 because we have specified varchar of 3. So it is actually applying the schema while reading the data. That is called a schema-on-read. But when we load, it did not modify the data at all. It just copied as is. Okay, so there is no schema on write. What is schema? Schema is nothing but column names, data types, constraints on top of them, the precisions. All these things are considered as schema. And in case of Oracle, when I say insert into a particular table, when I have data larger than the field which is defined as varchar of 3, it failed, saying that it cannot accommodate that value. But here it did not fail, it just loaded. So there is no schema on write. If you say insert, yes, it will apply schema up to a level. In this case, it just trimmed last 2 characters and it loaded the data. Only certain things will work. It might not apply schema always as you expect in traditional RDBMSs. Okay. But rest of the stuff, it does not apply the schema at all because it just copied the file. So if you have garbage in the file, when you query, you will get the garbage only. Okay, but when it fetches the garbage, it is just applying whatever it can. So it is applying schema at that time, and it is showing garbage in a bit different way. Okay, so this is very, very important to understand. That's why Hive load, there is no schema on write. But when you select, schema rules are applied up to an extent. So it is considered to be schema on read than schema on write. Whereas traditional RDBMSs are schema on write. Okay, it will enforce the constraint unless you disable them, but we typically do not disable them. Okay, so the whole explanation is primarily for you to understand the difference between schema on read and schema on write. Traditional RDBMSs are schema on write, and Hive or any database on top of big data, especially for batch processing, such as Hive, are primarily schema on read. Okay, and also as part of this, we understand many things. We inserted data individual record. It is slow, and we load the data with load command. It is fast because it copied the files directly. We have covered few things. We will reiterate those things again when we talk about DML at a later point in time. Okay. Now, what we'll do is we have. Do you have any question? No, you can ask. What if you have any question? Okay, okay. So we have our retail DB data in local file system. Now what we'll do is I will create tables for one or two tables, and I will leave rest of the stuff as homework to you. By tomorrow or day after tomorrow, you have to create all the tables for our data set, and you should have the data loaded into it. Okay, or at least create the tables even if you do not load the data. To test, you can insert, you can practice insert into and give the values, and make sure that data is loaded, and also make sure you query using select star from, but make sure you create the tables. Okay, so now comes creating the tables as per the structure in which we want to load the data. Okay, so first and foremost, what you have to do is you have to, typically in real projects, there will be multiple teams who will be working. Okay, so you might be getting this retail data from external teams. Okay, you might not have access to the database. Some team might give the data to you. So once the business requirements are determined, once the sources are identified to fetch the data, if the source system gives the data to you, okay, decided to not give but decided to give to you, then what will happen is there will be meetings between the team which is responsible to store the data in Hive and the team which is responsible to give the data. So there will be meetings in the between them, and there will be something called technical specification. Okay, and they have to come up with a technical specification which have both the teams consent. Both the teams have to agree on the technical spec. And what information will the technical spec will have? It will have the tables that needs to be loaded. Okay, if the format, sorry, it will have the tables from which the data needs to be fetched. Data source is identified. Now, as part of these discussions, they will identify the tables from which data has to be retrieved, and they need to discuss on what format they have to get the data. And then they also need to give the details about what is the field names, what is the field types, and if there are any rules that need to be applied. Okay, because if you are trying to get something like social security number or phone number or address, they are all considered to be private information of individual. If those information has to be retrieved, if do we need to get any additional approvals, or do we need to mask the data, or do we need to encrypt the data, all these details will be captured in technical spec. From our perspective, the most important technical spec is the file format, the delimiter, if it is text file format. If it is some other format like JSON, etc., you don't need to worry about delimiter. But if they are giving in text file format, you need to worry about delimiter. You need to decide which delimiter you will be using for each field, which delimiter they will be using for new line character, for rows, and also the column names, data types, etc. Typically, they share the data model also. Okay, so looking at the data model, looking at the sample data, there will be some sample data also as part of the technical spec. You have to come up with the create table command. Okay, so that is the typical practice which companies follow. You will not just go ahead and create some random thing. Okay, now we have data already. We have seen data model also earlier. Looking at data itself, we'll be able to figure out many things. Okay, so I'm going into retail DB in the lab. And there are 6 directories here. Each directory represents a table. So all these things have to be documented. So source team tell that we will be copying data to this location on every day, and the directory name will be like orders underscore date on which the data is loaded, or some other things. There will be some information. Or all these directories might be in a parent directory, and that directory might have the date. So that when I process, or when we process as data engineers, we know when the data come, and if we just have to take care of delta on every day, we should be able to write our logic based on the data names, and we can take it further. Okay. Now you see orders, and then look at the data. So the first field is order ID, which is of type integer. From the data itself, we can figure out. Second field is date. Third field is um, order customer ID, and fourth field is order status. So from this information, you need to map it to the Hive types. So first one is integer. In Hive also we have integer. Let us go through the documentation. Okay, we have integer, so we can define it as int. But if the value is very big, you can consider big int also. Then next one is date. We need to check whether we should use date or timestamp. If both of them do not work, then we have to think if there is any other thing which might work. So second thing, from the information perspective, it can be either date or timestamp. Do you want me to reduce the brightness? Okay. Okay. And the third field is again integer type or begin. Fourth one is string or varchar. You can define as varchar also. But now I will ask the question: should I use varchar or char or string in this case? In Hive, in Oracle, we should use varchar, and you can give the largest length, like varchar of 30 or something, which can hold all the statuses. In Oracle, we have to use varchar, because if you look at the data, there is complete, which is 8 characters, pending payment, which is 7, 8, and then 15 characters. Okay. So in Oracle, you should use varchar. Why we should use only varchar? First of all, let us understand the difference between char and varchar in Oracle. I have given you exercise yesterday. So what is the difference between char and varchar?
The basic difference is that character has a fixed
Mhm.
and
What is it?
static allocation.
Okay.
And varchar has an variable allocation. So there isn't any fixed length for varchar.
Yeah.
So like to suppress some space, we can use a character.
To save some space, not suppress.
Save some space. Whereas if you use varchar, more bit more memory.
No, that is not correct. Think about it. The first one is correct. Char is fixed. Varchar is varying. Var means varying. Okay. So anyone from online, what is the difference between char and varchar? And why should we use varchar here? Why should we use? I already explained, because we have variable length values for each status, and hence we have to use varchar. Okay, but when it comes to difference, what is the difference between char and varchar? One is char is fixed length, which means if you say, I will explain. I think you guys understand only the direct difference when it comes to allocation. So if you say char of 30 in this case, if you store complete is only 8 characters, but still it will allocate 30 bytes of space. What is it? Yeah, space will be unused. Why are you getting into array? Why are you getting into array? What is it to do with array? Tell me. That's what again you are why are you getting into array? Don't get into the unrelated things. You have very bad habit of that. Okay. So let me explain. Uh, so how the characters are stored in bytes, and each character takes 2 bytes. Okay. So if I say char of 30, it means it will allocate 60 bytes of storage in hard disk. Okay. Whether you store 1 character or 8 characters, for each and every value in that column, it takes 60 bytes of storage. If you say varchar, okay, it will only take as many characters you have multiplied by 2. So if you have one character, it will take only 2 bytes. It will, if you say if you have 2 characters, it will take 4 bytes. Okay. Then why we have char? So from the storage perspective, varchar is much better. It takes a lot less storage than char. Okay. Then why we have char also? You can just you can have it in varchar also. You can just have varchar of 10 and store the 4 numbers in them. Why it is faster? Why are you again getting into dynamic? It's not dynamic, it's varying. That's not why it will be slow.
Storage size of character is equal to the maximum size of the data that is being allocated.
Okay. So I will explain. The reason why we have char also, if you take the example of 4 numbers, it's always 10 characters. As you mentioned, char is a bit faster. And also on top of, so when it comes to varchar, if you say varchar of 30 and if you store only 1 character in one of the record, it will take 2 bytes to store that character, and also it has to store the information what is the length of that string. That additional information is overhead for each and every value which is loaded. Okay. So in this case, for complete it will take 8 plus whatever overhead it is. For pending payment, it will take that much plus overhead. If it is varying, then whatever performance you might sorry, not the performance. So here the difference is only on the overhead. If let's say there are 1 million records and all of them have 4 numbers, which is of 10 digits. Okay, if you use char, you have 1 million into 10. Why are you getting into fast? I'm not talking about fast. From the performance perspective, both will almost same. There won't be much of a difference. The primary difference is only on the storage. I am giving the example. Okay, if you have 1 million phone numbers and we know that each phone number is 10 digits, if you define it as a character and if you store those phone numbers, it will take 10 times 2 times 1 million, which is like 20 million bytes of storage. If you define the same thing as varchar, what will happen? It will take 10 plus 2 because we have to store the additional overhead details also, such as length. So it's not just 20 million, now it will be 24 million because you have to have 20 bytes for your data, 2 bytes for your length or whatever information you want to store, or 1 byte or 2 bytes, whatever it is. Okay, so you will have that additional storage wasted unnecessarily when you know that it's a fixed length. Okay, if you know it is not a fixed length, you have to define it as varchar, because in this case it is taking a lot less storage for each and every value than if you define as char. Now if you have data like this, if you have 10 million records, whether you use all the 30 characters or not, sorry, 1 million records, whether you use all the 30 characters or not, it will be using 60 bytes for each and every record, for each and every value, and hence you will end up using 60 million bytes of storage. Whereas you have mixed length, let's say on average, I'm not saying the actual length, but average length is only 15 characters, because some are in 20 character size, some are 10 character size, some might be 25. On average, let's say it is only 15 characters plus overhead. Okay, so what is overhead? Typically, it will be 1 byte because it stores length. So how much? 16. 16 times 2, 32 million. If you define it as char, it will be 60 million. If you define it as varchar, it will be 32 million. So as long as you know a particular field is fixed, the length of particular field is fixed, such as phone number, social security number, etc. You should use char, because you don't need to waste the additional storage unnecessarily. If you are not sure, then you should use varchar. Okay, so that is the difference between char and varchar. Now, when it comes to Hive, there is nothing like variable allocation or fixed allocation. Whether you define it as char or varchar, it will store the data in the same way. Okay, so it doesn't matter whether you define it as a char or varchar or string from the storage perspective. But when you load the data, instead of failing, it might load the incorrect data. So you need to be careful. Okay, but from storage perspective, whether you define char or varchar or string, it works the same way. So in this case, if I have to store this data, either I can give varchar of 30 or whatever it is, or I can give string, or I can give char also. It doesn't matter. You can give any data type that can store alphanumeric values. But if you want to give varchar or char, you need to be careful with the length. Okay. If you just do not want to copy the data type from the source system, just use string. If you just want to copy the syntax from the source system and then make little modifications. 1 minute, let me finish. If you have a table in the source system, you can extract the DDL of that. And if you want to use it with the minimum modifications and create the table in Hive, then leave the data types as varchar of 30 itself, because we are getting data from source. So definitely, if it is working there, it will work here. Okay. So then you can decide whether to keep the varchars like that, or you want to change to string. But if you want to have complete control from your side, it's better to have string. Okay, so either you can use string or varchar of whatever length the source system is using, or char. So what is your question?
How many bytes of memory is been allocated to string?
So string is nothing but, whether it is varchar or char or string, they are nothing but group of characters. Okay, it all depends upon how many characters are there, and there is no string type in Oracle. String is only Hive. In none of the RDBMSs there is string type. There is only varchar, char, and there is something called clob, which I will talk a bit later. Typically, we use char or varchar in traditional RDBMSs. In Hive, we have string also. Okay, here either you can use string or varchar or char. It doesn't make any difference. Okay, so for this field, I will be using string. Yeah. One more difference is highlighted by Puru. So if you define the phone number as 10, and if you only store eight characters into that, the other 2 characters will be padded with spaces. Okay, because it has to satisfy that length. It has to put something in that uh, uh, in that unallocated bytes. So it will just put space. That is another difference. But the more important, char should be only used if all the values follow the same length. Otherwise, char should not be used. Otherwise, you will be running into these kind of issues also. Okay. So now let us define the data type for this data while creating the table. So I'm creating the table orders. Create table orders. What is the first field? Order ID. It is of type int. Typically, when you say order date, you tempted to go for date or timestamp. Okay, here you need to understand the what is the default date format, what is the default timestamp format, and how the data is in our data. So before defining the data type of order date, you need to run some queries to understand the default formats. So I'm not creating the table yet. What I will be doing is I will be running simple query called select current date. So this will return today's date in whatever format the underlying engine treats the date as. You can see here the default date is in this format YYY-MM-DD. If you look at our data, it has timestamp also, like all the zeros are there. So I cannot just use date. What will happen if I say date and load this data into it? What will happen? Will it fail or will it? So let's say I created the table with the second field as order date and data type as date, and I loaded the data using load command into the table. Will it fail or will it load? No. My question is, when I issue the load command into the table with order date defined as date, and if I load this data into the table, will it fail or will it load successfully? What is that? What do you think? What people online think? Will it fail or will it succeed? Vamsi, why it will load? Why it will load? So I have spent almost 20 minutes to explain that. The answer is it's schema on read, not schema on write. It will not apply the schema when you load the command. I have shown the example also by loading the data which is not in compliant with your structure. And what happened? It loaded successfully, but when I query the data, it showed null values wherever the stuff is not matching. So that is the same thing which will happen here. Okay, if you load the data, load will be successful, but the dates will be shown as null. Yeah, that is correct, Ram. Srikanth is complaining that my voice is breaking. Is it only with Srikanth or is it with everyone? Please confirm. Yeah. So it seems to be a problem with only Srikanth. Now let us also, there is another data type also, timestamp. So we need to check how the timestamp is represented if we want to use, because the natural tendency is to either use date or timestamp. So let us issue the query, select current timestamp, and you see timestamp have 2 digits colon, which is nothing but hours, colon minutes, colon seconds, dot milliseconds. And if you look at the data, this is how, that is how it is, right? So we can try timestamp. So let us use timestamp here. So I will be creating table now. Create table. Order ID int. Order date. Timestamp. Order customer ID int. Order status string. And then if I just create table like this, the delimiters will be null characters. Okay. So let's if I create table like this, and now if I load the data into this table, will it succeed or will it fail? I just create table like this, and I just load the data into the table, issuing the load command. Will it load or will it fail? It will load and shows null characters. That is correct. Or it will show some inconsistent results. Sometimes it shows null, sometimes it might not. As long as the data types match, it might show one value and then remaining nulls. So there is no one particular way. Either it will show some or all as null values. Okay, so we cannot do it like this. We have to say row format. I will explain this row format in detail tomorrow. For now, just understand that this is the syntax which you can use. Fields terminated by comma and hit enter. Now the table is created. You can get the details about the table. So this is the location of the table, and you can see the field delimiters. Okay. So I will give this for you. So please make sure you have a copy of this before the session is ended, and you can use it as reference. And create rest of the tables also. We have 6 directories, and you have to create tables for all the 6 directories. So you need to go to the data model to get the field names. I memorize the column field names. That's why I'm directly getting into that. But in your case, there is no way you can figure out the field names. What you have to do, if you are in a project, you have to refer technical spec. Here you have to go to the data model which I have shown in the beginning. I don't know whether you have idea about how to bring it back. If you are not sure, just search for Cloudera exercise 1, and the whatever link that comes, click on that, and it will give you the data model. Be patient for some time. Sometimes it will not be loaded immediately. Okay. So that being said, now let me load the data. Load data, local in path, and the location of our data is data retail underscore db orders into table orders, and hit enter. There are it's almost 3 MB of data, but it happened just like that. There are 68,883 records. 68,883 records. All the 68,883 records copied in a moment. If you issue insert commands by processing one record at a time in Hive, it will take at least a day. Each record it has to take 10 seconds. Okay. So now I can say select star from, but don't worry about load for now. If you want to test whether your data is your table is created and how the data is stored and all, what you are supposed to do is you have to insert data into the table. Just practice insert into table name values so that you recollect how to insert data individual records just for your just to be in touch with SQL. As I haven't covered load yet, don't worry about load. Just try to insert some random records and try to see whether you will be able to fix the results or not. And also get into the file system, copy the files, see how the delimiters are, play with the delimiters instead of comma, use a different kind of delimiter. You try all those things, and that's how you will be able to figure out slowly and steadily about what should be used when. Okay, so that is about today's Hive DDL as of today's class. Tomorrow we'll continue from here, and we will actually get into the additional file formats, and also I will give more details about row format, and also I will touch briefly about special types, and also we will see how to partition the tables and all those things. And then probably next week we will be getting into DML, and SQL I will be very fast because I have covered database essentials quite extensively. So you have to practice by going through those videos. I'll be very fast and I'll be covering only those aspects of SQL which are different from traditional RDBMS. I will mostly compare and contrast between the SQL which we have seen earlier and in Hive from the execution perspective. Okay. So that being said, if you have any questions, let me know. Otherwise, we'll wrap up for today. Meanwhile, those who joined from YouTube, thank you very much for joining the session. We just want to give idea about how our typical classes will be. This is a 4 to 5 month long-term boot camp where we are covering starting from Linux, then database essentials. Then after 2.5 months, we actually got into big data, and we will be focusing on big data going forward. We'll be also creating a self-paced course in future. So if you are interested, you can follow us on our social networking platforms and stay up to date. And whenever the courses or modules are launched, you can subscribe for them. Okay. That being said, it seems there are no questions from the students. Hence, I'm wrapping up. Thank you.